Today we're going to talk about the HL theorem, which stands for hypotenuse leg. And up to this point, we've only had theorems that have S's and A's in them, which stood for sides and angles. So let's talk about hypotenuse and leg. Hypotenuse is a very specific part of a triangle. It has to be part of a right triangle. Remember, the hypotenuse is the longest side in a right triangle, and the leg is just going to be one of these other sides that is not the hypotenuse. So it can be either this side or this side. So let's look at these two triangles here. We've got triangle sum and triangle now. And we want to see if these are congruent to each other. Now, if we know that a hypotenuse, which would be this side and this side, if those are congruent to each other, and we know that the leg, let's say this leg and this leg are congruent to each other. This theorem is supposedly saying that these two triangles are then congruent to each other. Now, based on the theorems that we already know, we have two sides and an angle, and we've already said that if we have two sides and an angle, then that's not enough information to prove triangles are congruent. Remember, that would be like the situation SSA. So what makes a right triangle unique? Well, let's think about a more specific case, and this might help us. Let's say if these are congruent, let's give them an actual unit. Let's say that this is 3 units long, and this side is 3 units long, so those are congruent to each other. And this hypotenuse is 5 units long, and this is 5 units. So if I wanted to find this third side, what could we use in a right triangle to help us find the third side? Well, you got it, the Pythagorean theorem. That's what is different about a right triangle than all the other triangles, is we can use the Pythagorean theorem. Remember, that's a squared plus b squared equals c squared. So if I do that, then I've got 3 squared plus b squared equals 5 squared, which is 9 plus b squared equals 25. And then I just subtract that 9 on both sides, and I get b squared equals 16. And then take the square root on both sides, and b equals 4. So I would get b equals 4 right here for side UM. And then if I did the same thing over here, and I could do the same thing because, remember, these are just congruent sides, so I'm going to get rid of this. They're congruent sides, so my work would look exactly the same. So this would also be 4 over here. And so why is that important? Well, if I know that all 3 sides are congruent, that's using SSS, isn't it? So HL allows us to basically sidestep all the Pythagorean theorem and the SSS. We can just go straight to HL if we recognize that that's a right triangle. So here's the official theorem. It says, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of the second triangle, then those two triangles are congruent to each other. And remember, they may not always be oriented the same way either. If I had triangles that look like this, I have a leg and a leg congruent to each other. What about the hypotenuse? Which side is the hypotenuse? Well, that's this side that they have in common. So since that is the same line that is congruent to itself, remember that's the reflexive property, and so we would know these two triangles are congruent by the HL theorem. Let's look at a few more examples. So we need to decide whether we have enough information to prove that these two triangles are congruent, and if we do, then we're going to say what theorem that is. So we have right triangles here, so that's good. So let's see if we can use the HL theorem. We definitely have this side that they share, so that side is a leg, but do we know that the hypotenuses are the same? Are those congruent? They didn't say. So we can't really say that these two triangles are congruent. We don't have enough information, even though they may look like they are congruent. Over here, let's go over here. This one, we have right triangles again, and they mark the hypotenuse congruent to this one. And then we also have this leg down here, this short leg is the same line. So that's using the reflexive property. We know that that is congruent to itself. So we have enough information, so we can say these two triangles are congruent by HL. Let's look at one more. Let's say we know we want to use HL. So these are right triangles, and we need to figure out what's the other piece of information that we need to know. We're given that RM, that's this side right here, is congruent to FB, this side over here. So I'm marking those congruent so I can visually see what's going on. And then we also know that J is the right angle. So that's the right angle right there. And it says J is congruent to D. Okay, so I'm going to mark D as my other right angle. So what else do I need to know if I'm going to use the HL? Well, we already have the hypotenuse, and we already know this is a right triangle, so I really need to know a leg. So I either need to know JM is congruent to DB, or I would need to know JR is congruent to DF. And you know what? Let me put a double tick mark there. I don't want you to think that that's congruent to the hypotenuse as well. So we would say, well, we need to know JM is congruent to DB. Or like I said, the other option is to say JR is congruent to DF. So now we have another shortcut for proving triangles congruent, and that is the HL theorem.